This is the second of two videos. This is on Coriolis Effect and its impact on the horizontal movement of air. Now, as you remember, forces on air come in two different flavors. There are true forces and there are fake forces. And you think of true forces and that feather from Forrest Gump. And there are true forces acting on that, as well as fake forces that are seen only in accelerating systems. Let's review the true forces first. The true forces involve gravity that slows the convection of the air that is trying to rise, because gravity is pulling it back down again and slowing its ascent. On wind, there are two true forces. One is pressure gradient force, a major one, and the other is friction, which acts opposite to the direction and the speed of the wind. Now, these fake forces are seen only in accelerating systems. And remember, acceleration in physics is changes in speed that are consistent or changes in direction. In this case, we're really going to look at changes in direction. You remember this slide. Some other types of fake forces in physics include things that you know every day. When you go to an amusement park, centrifugal force keeps you from flying out of the tilt-a-whirl. When you take the curve just too fast and you haven't applied the brake before you entered the curve, you feel centripetal force when you lean in or when you are forced to lean in to the curve. When you have a sudden movement forward and an accelerating movement that changes direction forward very quickly, you might notice G-forces that pull your skin back. And the one that we're going to talk about here is the Coriolis Effect, a fake force that was really highlighted by World War I and artillery that was going much farther distances than it had ever gone before. These fake forces change the direction of a vector, but do not change the speed of a vector. And that is why they're called fake forces, because true forces would impact not only the direction of the vector, but also the speed. These are fake forces that just change the direction. I have 3 analogies for you, and I hope you'll stop the video here and take a look at them. If you can't click on the links, I gave you the Google keywords underneath it. The first analogy that you may recall from our video is the cloud racing ahead from the equator, or the cloud falling behind from the North Pole. When you watch that video, please only watch the first minute and 20 seconds. The rest is incorrect science. The direction of those winds is given incorrectly. But the first minute and 20 seconds is great. The second analogy is about the paper airplane flying north from Texas and trying to get to Nebraska. It's not as flashy as the first video, but it does have good science. And the third analogy is one that I made up about the moving sidewalk in Newark Airport. So I'm going to show you that one in case you don't get to the videos. And remember, you can stop here and read my analogy, but this is about the wet paint and you walking across that moving sidewalk because you've got to get over to the janitor's closet and get this wet paint off your feet. And you decide to walk directly across the moving sidewalk, and of course, you don't get directly across the moving sidewalk, you get pulled to the right. In much the same way as the counterclockwise direction of the Earth pulls you to the right with the Coriolis Effect. Now, I have a great video that you can look at in this chapter review on Blackboard and on my YouTube video, my YouTube channel. So look for the balloon, the purple balloon, in the thumbnail of that video. And I think it will really help you out to understand Coriolis effect in the Northern Hemisphere and in the Southern Hemisphere. Let's talk about it in the Northern one more time. As you know, the Coriolis effect deflects wind. It has nothing to do with convection. It deflects wind to the right of its intended target. And it deflects not only wind, but planes and artillery and ocean currents too. It deflects it to the right in the Northern Hemisphere. In the Southern Hemisphere, you deflect to the left. If you want to be convinced of that, you really should see my purple balloon video, because I do a demonstration there. When we talk about the Coriolis effect and accelerating systems, the stronger the wind, and let me put it this way, the greater the acceleration of the wind, in speed, in direction, or both, the greater the deflection. In the Northern Hemisphere, that is to the right. The amount of that deflection in the accelerating system depends on the altitude above the surface friction layer. Higher altitude, less friction, more speed, more deflection. The latitude of the item that is moving. For instance, the cloud that is moving up from the equator, or the paper airplane that is moving from Texas. The latitude of that has a lot to do with it. At the equator, that cloud is going to be moving at the speed that it originated in. But as you know, and as you can go through in the other videos on Coriolis, the equator spins faster than the poles. So as you move toward the poles, you're going to see a greater deflection as you move toward the slower areas and the slower rotations. You see this impact on long distances, and you see this impact at high speeds. Perfect for artillery, perfect for planes. So take a look at my other videos. This is just a review video. Take a look at the other videos on Blackboard in Chapter 6 and on YouTube on the Coriolis effect for a better understanding of the speeds around the equator and around the poles, and a better understanding of the latitude differences in this impact, in this effect. Take care.